In the next few minutes, you're going to learn this great Golang pattern that deals with default configuration and how you can override it to your needs. Let's first understand the issue. So, imagine you have this server and you are creating it with some default configuration. You have your timeout, address, port, protocol, etc. Now, you want the user to be able to change some settings, like for example the address or the port. So what is your option here? You can go here and pass some parameters to this function, like for example address, it's a string, and port integer, like this. Okay, when you are going to create the server, you will going to pass these parameters, like I don't know, address, local host, and the port is this one, for example. Now you will go here and say, okay, so how I can manage this? Maybe like this. So if address is like not provided, so is empty, we are going to do this, and like, okay, we have local host here, for example, and now we just going to do this. Okay, the same maybe for the port, like something like this, you know, it's 6969, like this, but this implies that you have to always provide here the port, or type 0 if you don't want any configuration. So it's tricky. And now imagine you won't let the user to change some more configuration in the future. So you created the server like this, and now this function is used in other environments. If you want to add new parameters, you have to change the signature. It means other files and other functions will change the signature, so it may become a mess. Now, how we can deal with this? We have few options. We can create a new struct, pass these options to the new struct, but I prefer to have my options in my main server struct. Here is where this pattern comes in very handy. We are going to delete anything inside here. Remove this. Okay. I will create my defaults like this, and the port is like this. Okay, if we have a lot of options, like default of configuration, we can create a function, put everything in the function, and call it from the function itself. But for now, it's like this. It's easier for the demonstration of this pattern. Just to read off of this, so my LSP is happy, I'm going to delete this. Nice. Now, what we can do to be able to change these configurations and maintain our ability to have this function even empty. In this occasion, the Variadics came very handy. So, for example, we can go to this function and call and add a parameter called options, or for example confs, configurations, no? And let's make them a string and makes them a Variadic. Obviously it's like this. What does this provide us? As you can see, at this moment our server, like our LSP, does not complaining. So this means we can create this function with no parameters. So it's already a default configuration. Great. Now let's just see, for example, what these Variadics are. Like we are going to print this like this, and I want to see all of the data in here. I'm going to print it. This Variadics, it's just a slice. So we can pass a slice of basically anything to this function, because, you know, this can be any, okay? And actually, this Variadic can also be a function. So we can pass a variadics of functions to this new server configuration. And what does this give us? In a function, we can do basically anything. So if in the function we pass like a pointer to our server, like this, what ability this give us? Basically, the ability to do anything we want, because inside a function, we can do whatever. So we want to be able to change the address. Okay, let's create a function that will change like the address. Okay, nice, great. And obviously we want to change a password. We want to change the address, so we are going to accept address as a string, okay? And now we have to figure out some way to actually update our server. Great. How we can do it? So we already talk about functions. Okay, so if I write a function inside this function and I provide to this function pointer to a server, okay, if I can do this, basically I could like just take this S, like so the actual server, and call the address on it and assign it to my actual address. But the LSP is complaining like something is not correct. How we can achieve this? Basically, we can return this function, and obviously in Golang you have to return this like this. And look at this. We are calling a function inside a function. And in this function, we are modifying a server struct. So we are modifying by a pointer something inside a different entity. Okay. And now what we can do is this. If we take this address like this and put it in the new server, for example, adding the new address, so remote host, for example. Look, LSP is not complaining because this new server configuration takes a variadic, so basically a slice in like bigger in terms, a slice of these functions. This function returns a function with a pointer to a server. So everything works fine. And we can now add how many of these functions we want without ever need to change our new server function signature. Obviously, at this moment in time, it doesn't apply. So if I closed my buffer, okay. So at this moment in time, obviously, this function doesn't apply. We have to create some way to apply this configuration, because yeah, if I going to like print this server, for example, printf my server like this, and I'm going to print like all the data we have, our main configuration for this server. Great. Now we have to apply our configuration variations, no? So how we can do it? Remember that this was a simple slice. What we can do with slices, like what the most doable thing with slices, range over them. For, and like we ignore the index, conf, okay, we are going to range over our configurations. And what we are going to do here, look at this conf. This conf is simple function that takes a pointer to our server. So call the function, take the server, put it here, pass it by a pointer, and voila. So what this for loop is doing, this is rage, okay, it's taking on each iteration of the slice of confs, it's taking this function and applies whatever we said, whatever we write it to do. So in this case, change the address. Now, if I run the test again, you see at the first iteration we have our local host, and at the second iteration we have the remote host setup. You see, with this pattern of configuration we can have our server even with like no parameters at all. So we have our default configuration, and if I run it, it's the same, nothing changed, but I actually can add more. So for example, I can create another one, like I can call this port, and like this. Okay, now I can simply take this, simply take this, put it here, pass it a new port, done. And this server configuration, this new server function, it's never changing. The signature is the same. It's so beautiful, like, and so elegant. It's great. One pro tip, it's that usually with this pattern, the developers add the word with, like before you call your function, like with, okay? Because actually you are doing this configuration with something. So you are telling, okay, I want to create my new server with address, with port, okay? And it makes sense. It's not like a mandatory operation, but if you are going to use this pattern and work with other developers, it will be very, very appreciated. Now, just for like a beauty pass, this returns like func to a pointer to a server, it looks a bit ugly. And just for readability of the code, we also can create an alias for it. Like we have type, for example, server opts, okay? And it's going to be equal to our function like this. So we can just go here, replace it like this with in our returns, for example. We can also replace it here like this, and we can run it and see the actual function working. So the default configuration is localhost and port 6969, and this is the new one. So today we have learned this great pattern that you can use in your libraries, in your own server configurations, in any kind of configuration actually. So use it, and if you like the video, give me a like, subscribe, and see you next time.